Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science Learn with Passion. In today's video lecture, we'll be seeing about the scheduling algorithms. Under that, we'll be seeing about the first come first serve scheduling algorithm. In our previous video lecture, we saw about the scheduling criteria. Now we are moving to scheduling algorithms. And before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And now we are available in our socials, Instagram and Facebook. Do follow us and do support us. Let's get started. In this video lecture, we'll be now seeing about the first come first serve scheduling algorithm. So far we have covered these many topics in first unit, and now we are in scheduling algorithms, and there are different scheduling algorithms. Like we have 6 different scheduling algorithms: first come first serve scheduling algorithm, shortest job first scheduling algorithm, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. And in this video lecture, we'll be seeing about the first come first serve scheduling algorithm. Alright, so let's start. First come first serve scheduling algorithm. By far simplest CPU scheduling algorithm is first come first serve scheduling algorithm. That is, in short, we say it as FCFS. Process that requests the CPU first is allocated the CPU first. Implementation of FCFS policy is easily managed with the FIFO queue. So what they say is, it is the simplest of all the scheduling algorithms. Why means the process which comes first will be getting the CPU first. So it is first come first serve scheduling algorithm. It is similar to the normal queue which we follow in getting for example, in getting a ticket. The person who enters the queue first will be the one who is getting the ticket first, and the person who comes next will be the one who is getting the ticket next. And when it follows the rule strictly, the person who comes last will never be able to go front and get the ticket first. So the person who enters last will be getting the ticket in the last. So same way, first come first serve scheduling algorithm follows the same rule. That is, the process which comes first in the ready queue will be the one who is getting the CPU first. Okay, and implementation of the FCFS policy is easily managed with the FIFO queue. What it means, they follow this first in first out queue. That is, this queue will have the processes lined up, and the first process P1, say for example P1 is the first process, it will be in the head of the queue, and the same way, and the process which comes in the last will be in the tail of the queue, and the process which comes in which is in the head of the queue will be getting the CPU first. And once the process which is in the head of the queue is allocated to the CPU, the process that is next to the first process will be now the new head. And if a new process enters into this first come first serve enters into this first in first out queue, it will be the tail of the queue. Okay, so so what we have to understand, there is a FIFO queue, first in first out queue, and the process which is there in the first will be the head of the queue, and the process that joins the queue in the last will be the tail of the queue. All right, and once the process which is in the head of the queue is getting the CPU, the head will be moved to the second process. So now the new head that is, the second process will be in the head of the queue, and when a new process joins the first in first out queue will be the tail of the queue. Okay, let's move to the next slide. When a process enters the ready queue, its PCB is linked onto the tail of the queue, and when CPU is free, it is allocated to the process at the head of the queue. So this is what I explained. The process which is there in the head of the queue will be getting the CPU when the CPU is free, and the new process will be when a new process enters into the ready queue, it will be in the tail of the queue. Okay, and whenever the process enters into the ready queue, its process control block will be linked to the tail of the queue. Okay, so any process can join the queue from the tail of the queue. Okay, The running process is then removed from the queue. So once the process gets the CPU it will be removed from the queue and the head will be moved to the next process. The code for first come first serve scheduling is simple to write and understand. So as the name implies, it is first come first serve scheduling algorithm, and the code for writing this scheduling algorithm is also very simple. All right. So average waiting time under FCFS policy is often quite long. So they say that the waiting time for a process under FCFS policy is always quite long. Why they say like this? Let us understand this through a example. Okay, consider the following set of processes that arrives at time 0. Process P1 arrives and it requires the CPU. That is, the burst time here is the CPU time. It requires the CPU for the process P1 requires the CPU for 24 milliseconds. That is what is the burst time here. Okay, process P2 requires the CPU for 3 milliseconds, and process P3 requires the CPU for another 3 milliseconds. So burst time is nothing but the time each process requires the CPU for their use. Okay, so each process requires the CPU for these many milliseconds. So what happens now is, if the process arrives in the order P1, P2 and P3 and are served in the first come first serve scheduling algorithm. So they are arrived in the order P1, P2 and P3, and they are using the first come first serve scheduling algorithm. So we get the result shown in the following Gantt chart. So how from time 0 to 24 milliseconds, process P1 will be using the CPU. So process P2 will have to wait for first 24 milliseconds, and it will be allocated to the CPU after 24 milliseconds. So process P2 will be using the CPU for the next 3 milliseconds. So the process which came after that, that is the process P3, has to wait for 24 plus 3, 27 milliseconds. So process P3 has to wait for 27 milliseconds. Okay, and it will be using the CPU for the next 3 milliseconds. So totally 30 milliseconds the CPU will be used. So what will be the average waiting time? The waiting time of process P1 is 0 millisecond because it came first, and the waiting time for P2 is 24 milliseconds, and the waiting time of P3 is 27 milliseconds. So the average waiting time is thus 17 milliseconds, okay, which is quite a big amount. So that is why they say the average waiting time under FCFS policy is often quite long. Okay, so let's see like this in the next slide. If the process arrives in the order P2, P3 and P1, however, the result will be as shown in the following Gantt chart. So if we change the order, for example, if the process arrives in the order P2, P3 and P1, the process P1, that is the process P2 will get the CPU first, and it will be using it for 3 milliseconds. So the waiting time of process P3 will be 3 milliseconds, and after that it will be using the CPU, and it will be using the CPU for another 3 milliseconds. So process P1 has to wait for 6 milliseconds. So the waiting time of process P1 is now 6 milliseconds, and it will be using the CPU for the next 24 milliseconds. So total 30 milliseconds the CPU will be occupied. So here the waiting time of process P1 is 6 milliseconds, and the waiting time of process P2 is 0 milliseconds, and the waiting time of process P3 is 3 milliseconds. So what is the average waiting time under this order is the average waiting time is 3 milliseconds. Okay, so in that previous thing, the average waiting time is 17 milliseconds, and now it is 3 milliseconds. So this reduction is substantial, That is, we have to give a considerable importance. Thus, the average waiting time under FCFS policy is generally not minimal. So, it is not minimal always. It is dependent upon the burst time of the individual process. So, it is not minimal and vary substantially if the process CPU burst time vary greatly. So, CPU that is the processes CPU burst time is varying. The average waiting time will also be varying. Okay. So one thing we have to see is FCFS scheduling algorithm is non-preemptive. So what is preemptive and non-preemptive? So preemptive is the process P1 will be in the CPU. If the process P2 requires the CPU, it can based upon the priority, it can stop the process P1 and it can get the CPU back. But in this case, FCFS, first come first serve scheduling algorithm, process P1, it cannot be taken out of the CPU. Why? Because it is non-preemptive. You cannot stop any process that is running in the CPU unless and otherwise the process completes the CPU work and comes out of the CPU by itself, or it should come out of the CPU for some IO operations. That is, you cannot force any process that is running in the CPU to stop work. So that is, in simple words, what we can say is, once the process, for example, P1 gets the CPU, it will complete its work, then only it will come out. Otherwise, no other process can stop its work and bring the process out. Just because process P2 wants the CPU, it cannot stop process P1 and get hold of the CPU. So it is non-preemptive. So which means that any process that is running in the CPU will hold the CPU for its work. That is, when the process P1 enters CPU, it will complete its work, then only it will come out of the CPU. Or if the process P1 requires some IO operation, it will come out of the CPU. It will come out only by itself. No other instruction can stop it to come out of the CPU. That is what is non-preemptive. So FCFS scheduling algorithm is non-preemptive. That is, forcefully you cannot stop any process. So the next is, once the CPU has been allocated to a process, that process keeps the CPU until it releases the CPU. This is what I just explained. Either by how it will release the CPU, either by terminating or requesting IO operation. Either it should complete the work, or it might be in need of some IO operation, then only it will come out of the CPU. Otherwise, unless and otherwise, it will not leave the CPU. It will finish the work, then only it will come out. That is what is non-preemptive. So this for FCFS algorithm is particularly troublesome for time sharing system, whereas each user need to get a share of the CPU at regular interval. So since FCFS is non-preemptive, it will not be suitable for time sharing system. What is time sharing system? That is, each process will be given the chance of the CPU for particular time, for a particular burst time. After that, it has to come out. But whereas in FCFS, if once the process is allocated to the CPU, it will not come out of the CPU unless and otherwise it completes its work. Okay, because it is non-preemptive. So this FCFS algorithm is particularly troublesome for time sharing system. That is, it is not suitable for time sharing system where each user need to get a share of the CPU at regular interval. Okay. So it will be disastrous to allow one process to keep the CPU for an extended period. So what they say is, if see, as we saw in our example, process P1 is the biggest process, and P2 and P3 are smaller amount of time requiring process. So once the CPU is allocated to the process P1, which is in the head of the queue, it will be using the CPU for a longer period of time, and the other processes P2 and P3, which requires the CPU for a shorter duration, will have to wait for such a long time. And once the P1 comes out of the CPU for some IO operation, process P2 and P3 will process P2 will go and process P3 will go into the CPU, and it will complete its work quickly. That is, for lesser amount of time only they will use the CPU and it will come out. And while the process P1 has to, process P1 will be using the IO operation. So it will be again waiting for the IOs, and once P1 finishes the IO, it will again go and occupy the CPU burst time, and process P2 and P3 will, since it has the lesser amount of time to utilize, it will finish the work of IO operations quickly, and it will again wait for the CPU. So once the CPU is getting allocated to a bigger amount of time requiring process, the other processes which is having a lesser amount of time will have to wait for the big process to complete. So that is what they say. It would be disastrous to allow one process to keep the CPU for an extended period time. So why? Because the rest of the other process which requires smaller amount of time will have to be waiting for the bigger process to complete. Okay. So this is what is about first come first serve scheduling algorithm. So what we saw is first come first serve scheduling algorithm is the simplest and easy to understand scheduling algorithm, and the code for writing a first come first serve scheduling algorithm is also easy, but whereas it is not suitable in time sharing system. So it will be a disastrous thing. That is, the disadvantage of FCFS is it is non-preemptive. So it will not be suitable for a process which for a bigger process which occupies the CPU for a longer period, and the smaller processes which has to wait for the longer process to complete. Okay, this is what is all about FCFS. Okay, and in my next video lecture we'll be seeing about the shortest job first scheduling algorithm. All right, and yeah, that's all for this session. And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And we are available in our socials, Instagram and Facebook. Please do follow us and do support us. Thank you.